This is geometry lesson 912, which covers finding area of cones and isosceles triangles, as well as missing sides of both. The first question is kind of a review from 911. It says find the area and perimeter of a rectangular rug if the width is 12 feet and the diagonal measures 20 feet. So first of all, we know we're talking about a rectangle, so I would draw one. Then it says the width is 12. Usually when I think width, I think wide, which is side to side. So I will personally label this 12 just because that's how I visualize it. Then it says the diagonal measures 20 feet. So this is 20. Again, we've created a right triangle. So we're going to use the Pythagorean Theorem to find that missing side. In order to find area and perimeter, we need to know how tall the rug is or how long it is. So we'll start with the Pythagorean Theorem, which is a squared plus b squared equals c squared. In this example, we don't know a, but we do know b is 12, and we know that c is 20. Now to find a, we need to simplify and then solve for a. So we know that a squared is still a squared, and this 12 squared is 144. 20 squared is 400. 20 times 20 is 400. Now we will subtract 144 from both sides. We get 256. These chunga chunga and all that's left over here is a squared. And then to get a by itself, we need to square root both sides. So a is 16. That means that the rug is 16 feet tall or long. The other missing side is 16. Now they wanted to know the area. Well, to find area of a rectangle, it's base times height. So we're going to do 16 times 12, now that we know that missing side. We get 192 square feet because it's area. And then we need to know the perimeter. So what we can do, there's a couple ways we can do this, but we can do 16 plus 12 plus 16 plus 12, or, because we did that twice, we can do 2 times 16 plus 12. Which this is 28, and 28 twice is 56. So that means the distance around it is 56 feet. It's a huge rug. Next example is about a cone. So a cone's a little bit weird, a little bit different. A cone is a three-dimensional figure, kind of like an upside-down ice cream cone. The slant height is the same as the hypotenuse. This is the slant height coming down the edge of the cone. We use a lowercase l in cursive. A regular L looks too much like a 1, so we don't bother using that. The second part of a cone is the radius. So from the center of an ice cream cone to the edge of the cone, in that empty space, that's the radius. The radius is like a leg. And then last is the height. The height is from the center of the cone to the tip of the cone. The height is also like a leg. So if we were to redraw this triangle that I've kind of sketched out, we'd have slant height, radius, height. Normally we have a squared plus b squared equals c squared. But instead, we're going to go H is a leg, R is a leg. So it's the equivalent of saying H squared plus R squared equals slant height squared, or L squared. Keep the color coding. I used a black R right here. So H squared plus R squared equals L squared. So for this example, we have the radius is 12 centimeters and the height is 14. So height is 14 and the radius is 12. They want to know what is the slant height. 14 squared means 14 times 14 is 196. And 12 times 12 is 144. 196 plus 144 is 340. We need to square root both sides. And we get 18.43.